pipe underscore distance and backlink raster. So what we're saying here is that you have to create both the pipe, the cost distance and the backlink raster using the cost pipe raster as the cost raster and the pipe end location as the feature source data. Okay? So we are asking you to create, this is where the distance tools come in, right? A cost distance raster. Distance, legacy, cost distance. So I'm going to close this, and I'm going to add the cost distance here. As you all know, when you add cost distance, you have two outputs. You have the output distance raster and the backlink. We give you direction to create both. One's going to be called pipe dist, the other is going to be called pipe back. How does that work? Well, we connect the output from the cost pipe to the cost distance. It's going to be our input cost raster, all right? But it's still gray, meaning all the parameters have not been met. So, we tell you, use the pipe end location as the feature source data. So we see this, here's feature source data. Drop down, pipe end. We get this default output that we want to change to pipe underscore dist, right? We don't tell you to do anything with maximum distance, so leave that default. But we do say create a backlink raster. And to do that, you type in pipe underscore back here, and that is all we need at this stage. But as you all know, that doesn't complete our cost path. What we ask is feed those two outputs, the two green outputs that have not run yet, into the cost path tool with pipe start as the destination data, and choose the best single path option. All right, so cost path is right underneath the cost distance here. We drag that in. In this case, we can just simply double click. Our input feature, or input raster, or feature destination data is pipe start. Destination field is defaulted. We don't tell you to change it, don't change it. Input cost distance raster, as we were told, is, and you can see here the model variables, is going to be our pipe dist. And our input cost backlink raster is going to be our pipe back. Our output raster is going to be called cost pipe. And we are going to change the path type from each cell to best single. We don't say anything about force flow direction conversion to backlink raster, and we simply select OK. Again, auto layout. And in this case, I do want to, is that cost pipe? No. I don't want to call this cost. I guess we don't tell you the output name. So I don't want to use cost pipe. I want to call this, I'll just call this pipe path. All right. Any questions here? All right, this should look exactly like what you guys did for your least cost path lab. Okay, this piece may not be in there, but bottom line is this, the process is exactly the same as your least cost path mountain lion LCP lab. So if you have any confusion, just go back to that PDF. Follow the same instructions. All right? So, I'm going to right click and add this to display and run. As you will recall, when you run a least cost path, you should get a raster with two values, 1 and 3. Okay? Always smart to look at the attribute table, and sure enough, what you'd expect, you have one cell with a value of 1, right? That destination, and then 3 makes up the path, and there are 1,465 in this case. Well, how do you see it? You need to turn off your other layers. I'm gonna leave my world's transportation on because this helps you identify the path. And in web courses, there is a map with labels for you to basically gauge where this path runs. And if you're looking at this, you can actually turn on your land cover as well, right? If you want to change this value, this color here, you can do that to something that's a little bolder. All right, you can see the red here, or make it black. Okay, you can see the black here, and you can see that that first location roughly crosses that B label. As you continue following, that path roughly crosses the E label. You keep on going, and you see it finally crosses here, essentially that H label. So if your answer to the next question was, compare the resulting optimum pipeline path with the marked locations A through I, which of the following sets of points matches the optimum path. If you selected B, E, H, you did this correctly. All right, any questions on least cost path?
It's supposed to be, you're following 1, not 3?
What's that?
So you say you're following 1, not, or you're just going by which one goes over those preset marks?
Yeah, so the map in web courses has the labels.
Okay, I got it. I see what you're saying.
So you're eyeballing your path, comparing it to the map in web courses to identify the path, the labels. All right? And you can see here, this is what I'm looking at here, right? You're just eyeballing. Okay? All right. So now you can answer these questions, and I know we're getting close to out of time, but I'm going to continue. So if you do want to leave, you can. If you want to see a shed, stick around. All right, so examine the attribute table of the output least cost path raster. What is the raster cell count for the optimum path, right? Value 3, as we just showed, it's 1465. And what is the approximate length of the optimum path pipeline in meters? Well, as you guys saw when you created the raster, the resolution was to be 10. So if you simply multiply 10 by 1465, 14,650. All right, that's not absolutely accurate. If you had measured it, it wouldn't be 14,650 meters, but essentially multiply those cells, those rasters, right? Multiply the count by the resolution 10, you get 14,600. Any questions on that? All right, view shed introduction.